As you guys are working really hard on muscles, I'm going to go back and pick up integumentary system because it's not outrageously difficult, and it's going to take you a while to work through muscles in lab. So this is like kind of an easy topic to add while you're working through that. Okay, so I want to talk about the skin in a couple of different ways. First of all, the skin is an organ system, the integumentary system, because an organ system needs to have at least two organs, right? So the skin itself is an organ because it's got at least two tissues. And then there's a whole bunch of other structures associated with the skin. We don't learn most of them just because of time. But for instance, if you looked at the skin as an organ system, you would have the epidermis and dermis alone that made the integument, which is the organ. But then if you added in like the hair, the nails, the sweat glands, the oil glands, the erector pili muscles, all of that, then it's actually an organ system. Okay, but I don't usually ask you about these, so if they're not in your notes, realize you're probably not going to be asked any detail about them. Okay, so the skin as an organ is also called the integument or the cutaneous membrane. And remember when we did the histology chapter, we said the simplest organs are membranes, and the cutaneous membrane was one, and then we had a mucous membrane, and then we also had a serous membrane. Those were the simplest organs. So right now I just want to talk about the skin as an organ. It is actually the largest organ in the body. The only one that's anywhere near its size is the liver, which is pretty darn big. But depending on your body size, the skin will weigh between 6 and 9 pounds. And that is not including the subcutaneous layer that may have adipose in it. It's just talking about the epidermis and the dermis. And if you stretched it out, it would cover, depending on body size, about 2 square meters of surface area. And it's really variable in thickness, from about 1.5 millimeters, which is teeny tiny, to about 4 millimeters, which is still pretty thin, but actually relatively thick comparatively. So where do you think on your body your skin is thinnest and thickest? So thinnest, what do you think? Think about, for those of us who are worrying about this now, or at least thinking about it, where does your skin wrinkle first? Tends to be thinner in that area. So around your eyes, relatively thin. Around your lips, relatively thin. And where is it thickest? The places that you would really need to exfoliate, for instance, the palms of your hands and the soles of your feet. So those are like the two sort of extremes in skin thickness and thinness. Here are the kind of two extreme looks. So this is thin skin. Thin skin is generally identified as thin by the thickness of what we call the stratum corneum, which is the top layer of the epidermis. And then this is thick skin, and thick skin has a lot of those dead cells on top. Okay, so the skin as an organ, again, is composed of two tissues that you've already learned. It's composed of the epidermis, which is keratinized stratified squamous epithelium, and then the dermis, and the dermis actually is sort of two layers. The dermis has areolar connective tissue and then dense irregular connective tissue. And then note to self, the subcutaneous layer, also sometimes called the hypodermis, is actually not part of the skin. It's usually taught with the skin, but it's actually not part of the skin. Okay, so, and you can see in this figure, so the epidermis here, the dermis here, and then we have the hypodermis or subcutaneous layer. And I asked you a question just because you've learned this before. You've got sweat glands and oil glands in here, and those are considered, what do you think, endocrine or exocrine glands based on what we learned in the histology chapter. Those are exocrine glands. Okay, so let's talk functionality of the skin, because a lot of times we don't appreciate the functionality of the skin, although a lot of us spend time thinking about the appearance of the skin. We don't think about the functionality of the skin. So let me take a second and say, okay, in what ways would you be at risk if your skin were not intact? So if you had lost sort of the intact coating of your skin, what ways are you at risk? So first off, most microbes cannot get through that protective keratinized layer. But if you damage your skin, of course, you've got the likelihood of viral or bacterial infection through your skin. So your skin is tremendously protective. It is the body's first line of defense from microbial invasion, because unbroken skin is a good physical barrier. In addition, you may never have thought about it before, your skin actually, the secretions onto the surface of your skin end up being slightly acidic, which is inhospitable to most bacteria. So it's both physically a protective barrier and also chemically a protective barrier. And then we will see that once you get into a certain layer of the skin, you actually have the first white blood cells. They have macrophage activity, and they're called Langerhans cells or epidermal dendritic cells. So the skin is physically protective, chemically protective, and then it's got cellular protection as well. And they actually help destroy pathogens if they get into the skin. And also they can take care of some cancerous and precancerous cells. Okay, the other thing, this keratinized layer is, of course, protection from dehydration. So you don't lose that much water out of your skin because of the keratinized layer. It also makes it so that water and water-soluble substances don't get in through your skin very easily. Your skin is also protective from mechanical damage, which seems kind of silly to think about, but when you run into something with your skin, you're not running into it with living cells, you're running into it with dead cells. And that actually helps protect your living cells from mechanical damage. And then we will spend some time talking about the fact that the skin is protective from UV damage as well. Okay, so those are all some your protection functions. Your skin is also, because of the glands associated with the skin, it does both excretion and secretion. Secretion is something that you make on purpose, and excretion is a waste product. Your skin also helps with body temperature regulation. First off, just intact skin is like closing the doors on your house. But then in addition, there's vasoconstriction and vasodilation. If I'm warm, I can vasodilate and send that warm blood to the surface, and then cool air goes across the surface. It's kind of like blowing on soup, and it will help cool down your blood, and then you take the cooled blood back to the warm organs, kind of like a swamp cooler. And then vasoconstriction, if I get really cold, I can vasoconstrict the vessels that are going to the surface and keep that warm blood closer to the core. And that tends to make my skin a little pale and sometimes even a little blue, right? Sometimes in your lips and the beds of your nails, you can actually see the skin turn a little blue when you're really, really cold. Your skin also has tons and tons of sensory nerve endings. Since it's your boundary between the internal and external environment, it's really good to know what's going on out there. So it has the capacity to detect touch, pressure, temperature, pain, all of those things. Oh, goodness gracious. Okay. Your skin is also helps with vitamin D synthesis. It doesn't do it alone. You need your kidneys as well. But when you're exposed to limited amounts of UV radiation, you don't need much. I'm not saying you need to tan. The skin in combination with the kidneys help to make vitamin D, which you need for calcium absorption. And of course, we need calcium for our bones, but other things as well. And then your skin is actually holding a disproportionate amount of your blood whenever you're not physically active. And then if you like start running or start working out, what happens is you shunt the blood away from your skin to, for instance, your skeletal muscles. So it's like a reservoir for your blood. And then it's also temporary storage of water, glucose, fats, and salts. So, for instance, under different hormonal environments, most of the women I'm talking to will know that your skin can actually retain quite a bit of fluids and salts. And then different hormonal environments, different time of your cycle, it will actually let go of those. Okay, so now to the structure. We'll put that in the next video.